SESCAD is a part of CDEX that you can specify your grounding grid, the primary grid that you want to study, and you will give the location of fault and conductor sizes, the depth of network in the ground, and anything related to the ground that you want to study. Basically, you will enter or you will import from other software to CDEX and SESCAD section. So SESCAD, you can find it with this little button here. I'm gonna click on that, and it asks me, do you want to open previous projects, or I'm gonna say no for now. Don't open any file, and it's gonna bring me just an empty section of SESCAD, and then I would be able to tell the software how much information and from where I want to enter. So I can create a new document. So this is a SESCAD environment. There is nothing for now, and I'm gonna create a new document. So it is similar to CAD pages. You see, pretty much you can zoom out and zoom in. And now you can start drawing your network, like using with these tools. Let's say this pen here, you can draw a conductor. You can click and drag and again click. So this will be a conductor, and you need to use a select object again to come back and right click on top of the conductor, edit object. This gives you the starting and end points. You can change X, Y, Z. And one important point here is Z direction is positive. So you have to use Z positive because software doesn't recognize minus Z because it's gonna be above ground. So for anything underground, you're gonna use positive direction. So that's just a little tip there. I'm gonna close it. But for sake of convenience, I'm gonna delete this, and I will use insert file, and I will import a file that I've already created from AutoCAD. You can get this from the designer groups. They have the grounding grid from the project that they are working. They can export a DXF file. So you're looking for DXF file, and if you double click on that, you will see a page like this, import filter, and it asks you default conductor radius. You can enter it here, and minimum conductor length, you can leave it 0, but it's important to change this one here, otherwise you will have to change it later, and it's easier to change from here. But But before that, we want to make sure our system of units are British. So let's close this before importing it. And look at this measurement tool. If you click on that, you see measurement result is on meter. So it's not on British system of units. What I will do to change that is I will define it from here. Define units and other settings. So you see it's on metric now. I will change it to British. It's important to do this because otherwise it's going to be a mismatch between your conductors that you are importing and you meant to be per British unit, and now it's on metric, so it's going to be a mess. So I will hit OK. But before that, you can always specify the project or the run ID. Let's say temp project, or use job ID, the main job ID that you entered in the first page. I'm gonna specify it and hit OK. So now it's on feet. Alright. I can go back and insert file from my desktop. This is the file that I'm gonna use, DXF file. Make sure it's DXF. OK. And four odd is usually a good conductor to start with, and it's pretty much standard. The radius, you will see later, I think it was 195 or 1. For now, I'm going to enter this feed and hit OK. And it says the total number of conductors are 109, and nothing, fortunately, is rejected for now. So I'll hit OK. And this is the network that I see here. If you see closely, if you look at them closely, one of them are blue. One is blue, and I will show why the color is different, but for now, the first thing that you want to do is you want to make sure this is underground before doing anything, because usually when you enter or import or insert from AutoCAD file like DXF, software doesn't recognize the elevation. So to do that, there is a very simple method that you can follow. If you look at these views, there are three basic views: XY plane, XZ plane, and YZ plane. You can choose any of this XZ or XY or YZ, I'm sorry. So this can give you the Z direction. So this is gonna be Z, and you will see it is above ground, as I mentioned. So you want to put everything below ground, and you can do that simply by choosing all of your conductors shift objects. And this shift page, you can specify the distance that you want to shift. I will use 1.5 feet, but this is the distance that it shifts. I usually start with 18" of underground depth. So first I want to know these conductors, what is the height of them. If you click on that and go to characteristics, you will see uh, indeed you need to right click and go to the edit object. But why it's not active? Because it selects everything together. It cannot select just one conductor. That's a good point that we need to first go to XY view, click on them and ungroup them. Ungroup. Now you can select just one conductor. So if you select one conductor, or let's go back to other view, you see it's easy to select just one conductor. And now you can right click on that and select edit object. Now you can see it is 19.5 feet above ground. As we previously said, negative sign shows you it is above ground, and we don't want that. So if we want to put 18" of underground conductors, you can add 1.5 feet to this many feet that is above ground. So I'm gonna shift everything basically to 21 feet to positive direction of Z, which is underground. So 19.5 plus 1.5 that I want to put my grounding grid is going to be 21. So I will close it and I will select everything. I'm going to Tools, Shift Object, and I will use 21 and toward this direction, move down. So if you click on that, I guess I clicked it too much, so I will click one and close it just to make sure the depth. You can click again and edit object, and now you see it is 18" or 1.5 feet underground. We will close it. You can hit save. Make sure to save the document. And I had this before, but I'm gonna use another name. Temp project. Okay. And we will use as a mulzi file. Okay. You can use mult and mulzi. And the big difference between mult and mulzi is mulzi considers the resistance and distance of big networks too. So they are very similar, but mulzi is complete computation than mult because it considers voltage drop and other stuff for big network too. I'm gonna hit OK. Now I can go back and to XY direction and maximize this first. Alright, now you have a basic grounding grid underground, and you have defined each conductor. If you go to the characteristic, you will see the radius, the primary radius that you used. If you click on these dots, you will see different options that you have. 4 odd, 3 odd, 2 odd. We use usually 4 odd. If you click on 4 odd and click OK, we would use 0191 when you first enter. I chose 5, but that's okay. You can use the correct numbers per your specifications. I'm gonna click OK. And now you need to define a fault location and amplitude of the fault, the grounding fault. This current, you can use ETAP simulation or utility data, whatever fault that you need to dissipate by this network. So either it's 5 kiloamp, 10 kiloamp. It's going to be based on your fault calculations, fault studies, which software that you use, which hand calculation that you use, the conservative one. Just remember, the fault that goes to ground, you need to consider that not three-phase like faults that they are symmetrical and then they are larger, but they don't go to your network, this grounding network. The two important fault that you need to consider is one line to ground fault and 2 lines to ground fault. Alright, and I will add just small stinger here, and which I can enter the fault value in this section. You see the energization, no energization now. We can define it here. So what I did, I put a small conductor here. You can right click on it and characteristics, and now I want to energize that. There's no energization level now, so you will need to define it, and you can click on these 3 dots. You can give a name like fault A, energization type, let's say it's gonna be current, magnitude of 5000 amp, angle 0. You can choose polar or Cartesian, and I will use bus number 1, faulted. Click OK. In this figure you can also see two buses. You can study two buses faulting at the same time. Bus 1, bus 2. We'll use just bus 1 for our simulation. Okay. And the radius type, we were using for odd, and that's okay. That's not very important for now. And there is